In this video, we are continuing to talk about partial fractions, and we will look at case 2, which is the case where my denominator, q of x, has a repeated degree 1 term. So what that means is, if I look at this denominator in my integral here, I have this 4x minus 1, and this is a polynomial of degree 1, ignoring the squared, because I have x to the 1 here. But it's repeated because when you square it, it means you're multiplying it by itself. So this 4x minus 1 shows up more than one time as a factor. So let's first remember, well, what did the partial fraction look like in our last example? So if I go up in our notes, when I had a fraction like this, my first step was factor the denominator. And in this problem, there were two different factors, and each of the factors had degree 1. Both of them had an x to the 1 technically. And then my partial fraction looks like, okay, the first fraction has this first factor on the bottom, and the numerator is just some number, which I called a. The second fraction has the second factor on the bottom, and then some number on the numerator, which I called b. And then from there, we did some algebra to figure out what the a and the b were. When I have an example like we do here, what the partial fraction will look like is, well, I already have the denominator factored. So if I first have a fraction where on the denominator, I just have 4x minus 1. On the numerator, I'll put a. There's some number there, so I'll just assign a variable to it. And then I will need another term, it turns out, where I do 4x minus 1, but then I raise the power. Now I make it a squared. On the numerator, again, I'll just put some number. I'll just call it b. In general, whatever this power was, like so if that was cubed, I would have had another term where I had that whole thing cubed and then another number like c on top. And I would have kept going like that up until whatever this power was. So if this was a 5, I would have kept going and had like a 4th power term and then a 5th power term. Okay. So for this example, we just stop at the squared. Now my goal is to figure out what these numbers a and b are. So we're going to do some algebra. I can simplify this if we multiply both sides by 4x minus 1 getting squared. So I'll do that on the left and on the right. On the right, I'm putting parentheses so that I remember that, oh yeah, this 4x minus 1 squared, it's going to have to distribute to each of these fractions, to this one and to that one. So when I do that, on the right-hand side, when I multiply it by this first fraction, it'll cancel one of the 4x minus 1s and leave me with a times 4x minus 1. When you distribute it to the second fraction, it cancels the denominator entirely away, and you just get plus b. On the left-hand side, well, it just clears out the 4x minus 1 squareds entirely, and you're just left with 8x minus 7. At this point, we can plug in some nice values of x to solve for the coefficients, because this equation should be true no matter what x is. So what are some nice values of x I can plug in? Well, I know that I can make this part go away and be 0 if I plug in 1/4. So let's plug in 1/4. X equals 1/4. And if I do that on the left-hand side, 8 times 1/4 is 2. So 2 minus 7. And then this part with the a becomes 0, and you get plus b. So nice, I get negative 5 equals b. So at this point, we know what b is. B is going to be negative 5. Awesome. There isn't really another super nice value of x that would like make this part become 0, because I'm plugging in for x. I'm not plugging in for a or b. So when there isn't a value of x anymore that will just like make one of these parts become 0, then I typically just plug in something very small and simple. And I think maybe a nice choice is something like 0 or 1. If I plug in 0, on the left-hand side, I get negative 7. On the right, we get, what, a times negative 1. And then plus b, which I now know is minus 5. So b is minus 5. Ooh, let's go to draw mode, minus 5. And that's that b. And if we simplify this, and I rearrange it, we can move this minus a to the left. That'll make it a positive a. I can move minus 7 to the right by adding it, and that'll give me a equals 2. All right, so I know what a is. I know a is 2. That's going to be this numerator of that first fractional term. So that's why my integral just becomes the integral of these two fractions put together like this. So 2 is the numerator of that first fraction, and then this minus 5, and I've just moved that minus in front like this, is that numerator of that second fraction. So I now need to figure out the integral, or the antiderivative, of each of these fractional terms, which are easier than the one that I started with. I didn't do this at the start of this video, which is, to think about like, well, would U sub have worked with something like this? I'd encourage you to pause the video, but try it. It turns out it's not helpful for this problem. And that's one of the reasons why I need a new method, like partial fractions, to handle this. Okay, so I got to do the antiderivative of each of these terms. So for this first one, this 2 is just a constant multiplying my fraction. So that'll just stay in front. And that'll multiply. And I know that if we have something like 1 over 4x minus 1, and this denominator is what's called linear, meaning it's degree 1, I know that antiderivative involves an ln term. I know it'll have ln absolute value, oops, let's switch to black here. I know it'll have ln absolute value 4x minus 1. And we saw this in the last video, but if I were to take the derivative, of ln absolute value 4x minus 1, we need chain rule. The derivative ln of stuff is, it's 1 over the stuff, 1 over 4x minus 1, times the derivative of the inside, which is 4. And, at this point, we've already moved this 2 out in front, which means in this integral, I just have 1 over 4x minus 1. I don't have this extra 4 that's popping out from the derivative. So to cancel that out, in front of this ln, we're going to need to put a factor of 1 over 4. Okay, so I can make an adjustment by putting an extra factor in front to make this work out, as long as this thing down here was linear. And it was 4x minus 1. It had degree 1. Okay, so what about for this next term? Similarly, I can just move the minus 5 in front, and that leaves me with like a 1 over 4x minus 1 getting squared. All right. I can move that squared up top to make this a 4x minus 1 to the negative 2. And ordinarily, if I have some complicated stuff to a power, I can't just do the reverse power rule, where I add 1 to the power and divide by that new number. But because this is linear in here, it's degree 1, we can make it work out using a factor to adjust at the end. Okay, so if I do my reverse power rule, we would get 4x minus 1, and then now the power is negative 1, and you divide by that new power, the negative 1. This is not quite right, though, because if I were to do the derivative of this, it would involve chain rule. So this minus 1 would come down, it would cancel this other minus 1. That would make this new power be a minus 2. So far, so good. But then you multiply by the derivative of the inside, which is 4. But there's no extra 4 popping out with this fraction that I have here. So I need to cancel out this 4 that pops out. And I do that by putting a 1 over 4 in front of this one also. Okay, so again, I can sort of fix this antiderivative by putting this extra factor in front, as long as what was inside here was linear, as long as it was degree 1. That won't work if this was like a 4x squared, for example. If it was degree 2 or something like that, this wouldn't work. And I would encourage you to think about why. Like to actually then take the derivative, if we did something like that, and see, okay, would I get back the original? Okay, so we got this. It's an indefinite integral, so I need my plus c. I can simplify this a little bit, because 2 times 1/4 is 1/2. So let's see, I get 1/2 ln absolute value 4x minus 1. And then we get plus 5 over 4 times 4x minus 1 to the negative 1 power plus c, and we got it. So there we have it. In the next video, we are going to do another partial fractions example, but where we will need to do long division first to handle it.